Morning. I, Bhavna Faculty, School of Finance and Commerce, Gulgutius University, is going to give a presentation on the topic Unbalanced Assignment Problem. The following are the prerequisites. Before studying the unbalanced assignment problem, one should know the basic concept as how to solve the assignment problem by the different methods. The next is we should able to understand the basic concept of dummy row and dummy column, that in the case we need to include any additional row and column, we should know the basic concept as how to add it. The following are the objectives. The first objective is to understand about the unbalanced assignment problem. The next objective is to solve the problem with the help of the practical questions. So, I hope that the first video of assignment problem will be very useful in understanding the concept. And in this video, we will be discussing the various types of the assignment problem, and in which the first part is unbalanced assignment problem. What is unbalanced assignment problem? As we know that the cost matrix of assignment problem is given to us in the question. Whenever the cost matrix of the assignment problem is not a square matrix, which means that the number of sources is not equal to the number of destinations, or the number of rows are not equal to the number of columns. So, in such a case, we need to add the dummy row or the dummy column in that particular matrix so as to complete form a square matrix, and the dummy row or the dummy column will contain all the cost elements as zeros. In the previous video, we have learned that how Hungarian method has been used to solve this problem. Now, in this unbalanced assignment problem, we will be learning that how to balance the assignment problem. Now, let us understand about the unbalanced assignment problem with the help of an example. Suppose that there are the taxi firms which are having three taxis. The taxis here are the three agents which are available and the three customers who wish to be picked up soon as possible. The firm prides itself on the speedy pickup. So, for each taxi, the cost of picking up each customer will depend upon what the time has been taken for that particular taxi to reach out the pickup point. So this is the balance problem, as we are having three taxis and three customers. So first taxi will be picking the first customer, second taxi will be picking the second customer, and the third taxi will be picking third customer, right? So this is a solution that whatever combination of taxis or the customers, it will result into the least cost. We can make the possible combinations of the taxis and we can make the possible combination of the customers along with that, so that we can have the least total cost, right? Because here we are having the equal number of agents and equal number of customers. But now, if we suppose that there are four taxis available, but there are only three customers. So this is the unbalanced assignment problem. Why it is so? Because now the taxis are more and the customers are less. So we need to assign it, because the equal assignment of the customers and taxis has been not been given to us. So one way to solve is to invent the fourth dummy task, that is like the sitting still doing nothing. So we are going to add the fourth dummy task in that, and that will be added with the cost of 0 for that particular taxi which has been assigned. So this reduces the problem to the balance assignment, and then we are going to solve the problem in a similar way so that we can get the best possible solution to the given problem. So let us learn how to solve the assignment problem in the case of unbalanced problem by using Hungarian method. So as you can see in this question, work and jobs has been given to us. So let us see that how we can solve this question. As we can see in this question that work and jobs both has been given to us, but the jobs has been given 1, 2, 3, 4, and the work has been given starting from alphabet A to E. We can find that there is a complete unbalance in the number of rows and columns. That is, the number of work is not equal to the number of jobs. So here we will be adding one more job, and hence we will be adding the dummy column, that will be J5 in this case, so that the number of work and the number of job assigned both should be equal to each other. And then we are going to find out the minimum element in each row. When we assign the dummy column, the minimum element in each row will be 0, and the maximum and minimum element in each column we are going to take. Let's find out the minimum element in each column. In first column, the minimum element is 7. So 9 minus 7 is 2, 7 minus 7 is 0, 9 minus 7 is 2, 10 minus 7 is 3, and 10 minus 7 is 3. In second column, we can see the minimum element is 12. So 14 minus 12, that will be 2, 17 minus 12, that will be 5, 18 minus 12, that will be 6. Like so on, we will be finding the minimum element in each column. In third column, we are having the minimum element, which is 18. So 19 minus 18 is 1, 19 minus 18 is 1, 20 minus 18 is 2, 21 minus 18 is 3, 18 minus 18 is 0, and 21 minus 18 is 3. In the third column, we find out the minimum element 15. So 15 minus 15 is 0, 19 minus 15 is 4, 18 minus 15 is 3, 19 minus 15 is 4, and 16 minus 15 is 1. And in the last column, we are having the same, that will be 0. In step 3, we will be making an assignment in each opportunity matrix. Let us assign in first column. It will be assigned where we are having 0. So we will be assigning in the first column where we are having the 0 element, which is in row 2. Then we will be assigning at the second column in the row D on 0. And in the third column, we will be making no assignment because we have already assigned the resource of job, that is job third, on the work, which is D. So we will be not making the another assignment in this column. In the fourth column, we will be assigning in the first row, and in the third row, we will be assigning at J5, which will be 0. Like this, we can see that in row third we have made the assignment, in row 2 we have made the assignment, row 1, row 4th. But in fifth row we have made no assignment, and in column third we have made the no assignment. So this is not going to be the optimum opportunity cost table. We are going to solve it more. As we can see that the number of assignments are 4, and the number of rows in that we are having 5, which is not equal. So the solution is not optimal. So let us cover the zeros with the minimum number of lines. So as we can see that we have covered this 0 by drawing a straight line. We can cover the maximum number of zeros by covering with the help of a straight line. Similarly, we have covered this zero with the help of the straight line. In this case, in column number 5th, we can cover the maximum zeros by drawing a straight line. Similarly, in the row 4th, we can cover the maximum zeros by making the straight line. So like this, we cover all the zeros in this question. The next step is to develop the revised matrix by selecting the smallest element. The smallest element will be taken from those elements which has not been covered. Like in this case, the smallest element was 1. So we are going to subtract 1 from the uncovered elements. Like in this case, we have subtracted the different elements like 2. In the case of this element, we have subtracted the different elements like 2 minus 1 is 1. So, like this, we are going to take out all the values, and where we are having the intersection point where we are having the two lines to be intersect with each other, there we are going to add that particular smallest element in that particular row or the column. So let us make the assignment in this question. Let us assign 0 in the column 1 and row 2, this 0 in column 2 and row 4, this 0 in column 3rd and row 1, this 0 in column 4th and row 5th, and this 0 in column 5th and 3rd row. So we can assign the elements according to the row wise and column wise in this matrix. The number of assignment, that is 5, is equals to the number of rows. Hence we get the optimal solution because the number of assignment of rows is equals here. So the solution is optimal. So let us calculate the optimal solution. Work A and job 3rd, in which we will be taking the initial table, which is 19. Job B and work B and job 1st, in which we will be putting the value of the initial table, which is 7. Work 3 and job J5, in which we will be taking the initial value, that will be 0. And work D and job 2nd, we will be taking the initial value 12. In the case of work E and job 5th, we will be taking the initial table value, which is 16. So let us make the total. Here we get the total of 54. So we can say the solution is optimal. I hope that this video on unbalanced assignment problem will be very useful for you in understanding the concept. Thank you for watching this video.